Hello viewers, welcome back to BakoMaths, and today's lesson we'll be looking at elementary row operations. And so if you have not subscribed to this channel, kindly subscribe for more updates. Let's get started. And so we start with the meaning of elementary row operations. So elementary row operations are the basic operations that are performed on rows of a matrix to simplify it or to solve systems of linear equations. And so the underlined word here is rows of a matrix. So if we want to perform elementary row operations, we don't perform to the columns of that given matrix, but rather the rows of that matrix. Now we know the basic operations. The basic operations we have in mathematics are the addition, the subtraction, we have the multiplication, and the last one, that is division. So when we have a matrix and want to perform elementary row operations, we are just going to use these basic operations on the rows of that matrix. Sometimes we use this to simplify the matrix, or we use it to solve systems of linear equations after we augment the matrix for that systems of linear equations. Now, row operations is very useful in Gauss-Jordan or Gaussian elimination. So before you carry on with Gauss-Jordan or Gaussian elimination, you should be familiar with elementary row operations. And with that, working with Gauss-Jordan or Gaussian elimination procedure becomes so easy. From here, we'll be looking at the types of elementary row operations. And with the first type, we have row swapping. Row swapping. So this operation involves interchanging any two rows of a matrix. The underlined word here is interchanging any two rows of a matrix. So when we have a matrix, what we are interested in is to interchange their rows, and that procedure is what we term as row swapping. So if we have a matrix like 5, 3, 6, -1, 2, 4, 0, 0, 0, we can perform row swapping on any of the rows. Remember that our first row, we call it row 1, and we can also call this one as row 2. We have this one as row 3. And with this, we can perform row swapping on any of the rows. So let's assume we want to swap row 2 and row 3. So we are interested in swapping row 2 and row 3. We can write it as row 2, row 3. Now this sign or this symbol indicates interchanging or swapping. And so if we see something like this in any matrix in terms of rows, it means we are interchanging their rows. Now we have our final answer to be written as, since we are not working with row 1, we write the same values for row 1 in our new matrix, and we have 5 here followed by 3, the last one 6. Now we are interchanging row 2 and row 3. So it means that the values of row 2 is now going to assume the values of row 3 in its position. So we have 0, 0, 0. In the same way, the values of row 2 is now going to assume the position of the values of row 3, and we have -1, 2, 4. So this is how we perform row swapping. So in any case, we can also swap row 1 and row 3. In the same way, we can also swap row 1 and row 2. So we can swap equally the other rows. And that is how we perform row swapping in elementary row operations. And we move on to the next type of elementary row operation, and that one is row addition. Row addition. This operation involves the addition of one row to another. The underlined word here is the addition of one row to another. So under row addition, we can add one row to the other row. So if we have a matrix as 1, -2, 4, 0, 1, 3, and 2, 0, 5, we can perform row addition. Remembering that we have this side to be row 1, the whole of this to be row 2, and the last one to be row 3. So in this case, if we want to perform row addition to the row 1, it means that our new matrix now becomes row 1 to be equal to row 1 plus row 3. That is when we have in mind we want to add row 1 and row 3, and then the effect is going to happen at row 1. So writing this, our new matrix becomes, since we are adding row 1 and row 3, we have 1 plus 2 gives us 3, and we write it at where row 1 is. Negative 2 plus 0 gives us negative 2, and so we write that one too. Now we have 4 plus 5 gives us 9, and we write that value. Now since we are not working, or we are not adding the rest of the rows to row 1, we leave them as we see. So we have 0, 1, and 3. And the last one, we have 2, 0, 5. And basically, this is how we perform row addition under elementary row operations. From here, we move on to the last type, that is row multiplication. Row multiplication. Now, this operation involves multiplying any row by a non-zero constant. The underlying word here is multiplying any row by a non-zero constant. When we talk of non-zero constant, they are any value apart from 0. And so we have negative values and positive values. So the idea is that when we take a row, we can multiply by any number apart from 0. So if we have a matrix as 2, 4, 6, and 1, 3, 5, to the last one, 7, 8, and 9, we can apply or perform row multiplication. So we also know that we have this one to be row 1, followed by row 2, and the last one, row 3. Now let's assume we want to multiply row 2 by 3, and we can write it as 3 times row 2. So the idea here is that we want to multiply row 2 by 3, and we can have our new matrix as, since we are not multiplying the rest of the rows by any number, we maintain that. And so we have 2, 4, 6, and then we are multiplying row 2 by 3, and so 3 times 1 gives us 3. 3 times 3 gives us 9. 3 times 5 gives us 15. Now, since we are not multiplying row 3 by any number, we maintain the values of row 3, and we have 7, 8, and 9. And this is how we perform row multiplication. In the same way, we can also multiply the rest of the rows by a non-zero constant. So we can also multiply row 2 by 4. We can also multiply row 1 by 4. We can also multiply row 3 by 5. So that is the idea. So having known this using Gauss-Jordan and Gaussian elimination in solving systems of linear equations, it becomes so easy. So if you know how to perform elementary row operations on the rows of a matrix, solving Gauss-Jordan or Gaussian elimination becomes so easy. And so this ends today's lesson. And so thanks for watching. Kindly like, comment, subscribe, and share. See you in our next video. BakoMaths, thinking beyond infinity.